So here we have another one. Show that for a body moving around a circular track of radius r at a velocity v, the centroidal acceleration is given by this equation. So we'll begin by first of all, begin by noting that this question is about kinematics. And we know that kinematics is the study of movement of motions of objects, or group of objects. So we'll begin by noting that acceleration this is general knowledge. Acceleration equals to change in velocity so just all over change in time. So that's general knowledge. So I want to prove this, to prove this expression over here. So they've said that show that for a body moving around a circular path. So let's consider this is the center of the circle, and this is the circle, and we have our object first. Okay, this object for the first time it will be here, so the second time it will rotate and it will be noted here. So this is the radius and this is also the radius. So okay, let's continue. Now we'll consider an object going around. We'll consider an object going around a circular path. Going around a circular path. So I will draw that. So I will draw that. So this is our imaginary round path that our object is supposed to be revolving in. So this is the center. Hope the circle is visible enough. So like this is the center of the circle, and this object at one point it will be here. So at one point it will be here. Use a line to indicate. Then at the next minute it will be there. So it will have moved from this point to that one. So this is the radius. Also this is the radius of the circle, and this will be the velocity. This will be v1, this will be v2. Velocity 1, velocity 2, where v is velocity, and r is our radius. So change in velocity, so we'll experience a change in velocity. So change in velocity triangle. Change in velocity triangle, I will draw that change in velocity triangle. I will represent it in form of a triangle. So it will go like this. Cancel. No, I will just change in velocity triangle. No, I'll use another method. I will use that triangle. Okay. There will be a change in velocity triangle. Hope the noise from outside is not too loud. Okay. This is our angle. This is V. This is V1. And this is V2, and this is the change in velocity over here. Also we know that let me find space. Also we know that change in V velocity multiplied by change in time is the amount of, this is the amount, just a minute, amount of time taken so this is the amount of time taken for the object to move, amount of time taken for the object to move. Yeah, amount of time taken for the object to move. Yeah, I'll write that down. The object to move. And we also know that theta if it is small, the line is straight. So this theta will be straight, will be a straight line. So I won't write that down. So we'll now consider another triangle. So in this triangle, this is our theta. That is our theta. This is R. This is R. And this is V changing time. This is change time, changing time. So we'll write here when the angle is small, the line is straight. Let me show you that line. So this is the line I'm talking about. this line from here to here. Yeah, that is our line. So here is where V is changing T. So this is the line I'm talking about. So let's go back there. So we will note that these two triangles, this triangle over here and this one, sorry for the inconvenience. So we'll note that these two triangles So we'll know that these two triangles, they are isosceles. Sorry. They are isosceles, and also they are hey. So and also they are subtended by the same angle. They are subtended so they are subtended by the same angle theta. Okay. By the same angle theta. So they are subtended by the same angle theta. So we know that from here, when we use SOHCAHTOA, we know that sine theta equals to opposite over hypotenuse. So it will be equals to, our opposite will be Our opposite will be this one here. So opposite will be V change in time all over hypotenuse. Our hypotenuse is R. So we get our hypotenuse as R. Also from this other triangle, when it gets sin theta, we will get it as opposite of a hypotenuse. So it will be, this is the opposite angle, will be change in V all over V. It can be V1 or V2, so we'll just write V. So let's take this to the other. This is our second equation. Okay, let's go back here. Also, we know that the other one we have gotten that sin theta is changing V over R. So when we take our two equations over here, it's changing V all over R equals to V and changing T all over R. So see, you remember we said that sin theta equals to, okay, let me rewrite it well to prevent confusion. We got that sin theta all over R. Also we got that sin theta, this is our first equation, also we got that sin theta equals to this one, so let's equate these two equations because they are similar. So we'll get that change in V over R equals to V change in T over R. So what about we divide both sides by both sides by V, both sides by V, multiply both sides by R, both sides by R. So what we will get, we get that change in V all over V equals to Now here, so here supposed to be, you multiply here by, you divide by t here, divide by t this side, multiply by r as I've said, so we'll get that. So this change in t divided by change in t divided by change in t this side, we'll get here change in t equals to wait, this is supposed to be v. I think I wrote it the wrong way. This is not no, not that one, this one over here. As you can see from our triangle, it's change in v all over v here, our theta. So I kind of wrote r rather than t, so that's a correction over there. So here it's change in v, not r. Let me rub it. Let me erase. Backspace. So here it's v. Yeah, it's v. Sorry for the inconvenience. So here it's v. So that here it's v also. When you multiply by v this side, you multiply by v this side, here we will get v squared. This v and this v will cancel out. Now here will be v squared divided by this r of ours over here over r. I think I should have just gone slowly, but if you factor out, it's simple. So this is our equation we have reached here, and from our beginning of the video we say that acceleration equals to change in velocity over change in time. So here, this change in v over change in time, if we replace it with AC, we'll know that AC, which is acceleration, this one, equals to v squared all over r. And by that, we'd have, by this one, we'll have proven our formula. So that's all. This is the answer. This is actually 6 marks. Hope there is no problem over here. But anyway, that's all.